Hello viewers, I am Kausalya. Today we are going to solve problem number 12. This is method 2. Already we have discussed method 1. Now we are going to discuss about second method of solving the same problem. The problem is obtain the state model of the system whose transfer function is given as, and this is the given transfer function. So the first step here is we are rearranging the given transfer function according to Mason's gain formula, right? Here Mason's gain formula comes under the topic signal flow graph. Now we are going to solve this problem using a signal flow graph, right? So here the first step is here the denominator term, the maximum power is s cube. So here I am taking s cube commonly outside. So when you take s cube, the remaining terms are, you see, what it means when you take s cube, that is we are going to divide this entire denominator part by s cube, that's it. So when you divide the entire part by s cube, the terms will be s cube cancel each other. So 1 plus here 4s square by s cube gives you 4 by s, and 2s by s cube gives you 2 by s square, and here 1 by s cube, right? Now just rearranging the above expression, I am moving this s cube to the numerator part. So 10 by s cube divided by, here I am splitting this plus into 2 minus, right? Because as we all know, minus into minus gives a plus, right? So here this plus I am dividing it into 2 minus. Therefore 1 minus of, here minus 4 by s, minus 2 by s square, and minus 1 by s cube, right? Now we are going to construct a signal flow graph. So you see this is the transfer function, right? From this transfer function we have to analyze how many individual loops are there and how many forward paths are there, right? So in the numerator I am having only 1 by s cube term, that is 10 is a constant, okay, it is a gain. I am having only 1 by s cube. So this means that this transfer function has only a one forward path, right? Therefore here you see this signal flow graph has a single forward path, right? Since I am having s to the power 3, that is 1 by s cube, it means that it has 3 integrators, right? 3 integrators, and the gain is 10 by s cube, right? And when you look at the denominator part, here we are having 3 individual terms. This means that this has 3 individual loops, right? So the graph has 3 individual loops with respect to gains. What are all the gains here? You see here the gain is minus 4 by s, minus 2 by s square, and minus 1 by s cube, right? This is what I had written here. Next we are going to construct the signal flow graph from the transfer function. So just now we had realized that this signal flow graph has a single forward path and it has 3 individual loop gain and 3 integrators are present because we are having 1 by s cube. So since we are having 3 integrators, you see we will be having 6 terms totally. That is, we have to select, since we are having 3 integrators, there will be 3 state variables, right? So the 3 state variables are respectively x1 dot, x2 dot, and x3 dot. So when you integrate these terms, automatically we will be having x1, x2, and x3, right? So totally we are having 6 variables, therefore 6 nodes. You see 1, 2, 3, 4, 5, 6. Apart from these 6 nodes, we should have an input node and an output node. So the input is denoted as u and the output is denoted as y. Right. So after fixing the nodes, the thing is, let the first node be x3 dot. When it is integrated, it becomes x3. Then x2 dot, x2, and x1 dot, x1. So the integrator is typically represented by 1 by s term, right? Therefore place 1 by s term accordingly. When x3 dot is integrated, that is 1 by s, it becomes x3. And x2 dot is integrated, 1 by s, it becomes x2. Similarly x1 dot when integrated, it becomes x1, right? So if you have any gap, that is, you see between x3 and x2 dot, there is nothing, right? This means that this branch has a gain of 1, right? Therefore represent it accordingly. So after representing these terms, then we have to proceed with our individual loops, right? We have to fix our individual loops here. So as usual, what is the first loop gain? You see the first loop gain is minus 4 by s, right? So the thing is, you see, it should have only 1 by, that is 1 by s term, right? Therefore, we are selecting a path such a way that, you see here we are having 1 by s. So I am having a, what to say, I am filling the loop, okay? I am fixing the loop over here with a negative, that is with the feedback gain of minus 4 here. Therefore, this loop has a gain of minus 4 by s. Okay, do you accept or not? Because here it is minus 4 and here it is 1 by s. When you multiply minus 4 and 1 by s, the output is minus 4 by s. So this is the loop gain, right? So our first part is over here. We had find out the loop gain for minus 4 by s. That is, we have fixed the loop for minus 4 by s. Then the next loop gain is, you see, it is minus 2 by s square. Right. Therefore, I need two s terms in the denominator. That is 1 by s into 1 by s. So when you move back, you see here I am having 1 by s and here also 1 by s. So when they two are get multiplied, I will be getting 1 by s square. So I am drawing a feedback path which has a gain of minus 2. So the total gain of this loop will be minus 2 into 1 by s square. Right. Then the next thing is, next loop gain is minus 1 by s cube. So minus 1 by s cube, again I need 3 1 by s terms. So here 1 by s, here 1 by s and here 1 by s. So the gain here is, you see in the numerator I am having only 1, right? So in the feedback path, it is enough when I include just minus 1 over here. Right. So now our signal flow graph is over. Am I making the concept clear here? First, we have to calculate number of state variables. That is, number of integrators will give you the number of state variables. Right, when you have 3 state variables, when they get integrated, you will be having the normal variables. So totally 6 variables are present. Therefore, you have to represent it by 6 nodes. Apart from these nodes, you will be having one input node and an output node. Right. So depending upon the integrators, first we have to start with x3 dot x3, likewise, okay, x2 dot x2 and x1 dot and x1. After fixing this, we have to represent this 1 by s values. Right. And here initially they had given in the problem a gain of 10. Therefore here in the input path we are representing 10 and the output path it is simply 1 here. Right. So after drawing this forward path, you have to go back to the loop gain. Okay, you have to fix the loop over here. Depending upon the values, you see the initial loop gain is minus 4 by s. So I need only 1 by s term. So here it is 1 by s. Therefore, I had fixed in the feedback path. The gain is minus 4, so that we are having the value of minus 4 by s. Right. So likewise, you have to draw the loops. Now we are going to frame the state equations, which are quite easy. First, we start with x1 dot. Okay, just draw the diagram. Here I am having x1 dot. Here it is x2 and here it is x1. So just draw the nodes which are occurring at the front as well as at the back. Right. So here from x2 dot to x1, here the gain is 1. So 1. And here from this x1, I am having an 1 by s along with minus 4 also. Right. Since this 1 by s contributes to the feed, that is forward path, okay, no need to consider while writing the expressions. You just take the respective values. So here it is 1 into x2, that is x2, and here minus 4 into x1, that is minus 4 x1. Right. Now we are proceeding to x2 dot. Again, when you look at x2 dot, you see from x3 there is a signal coming, and from this x1 there is a signal coming towards it. Right. So while writing expression, it is x3 and minus 2 into x1, therefore minus 2 x1. Similarly, we have to proceed with x3 dot. So when you consider x3 dot here, again here is a signal which is coming and here is another signal which is coming towards x3 dot. So when you write the expression, here it is minus x1 plus 10u. Right. So after writing all the things, we have to look at the output also. And here when you see the signal flow graph, The output y is nothing but 1 into x1, which is x1, right? Now we are going to represent this in the matrix form. So when you represent this in matrix form, as usual, the same case, x1 dot, x2 dot, and x3 dot, right? So here we are having a 3 by 3 matrix, and as usual, you just fill the matrix with the respective coefficients. Here it is minus 4, here the coefficient is 1, and there is no x3, so it is 0. So minus 4, 1, and 0 here. Likewise, you fill the remaining rows, which gets multiplied by x1, x2, and x3. Plus, regarding input, you see there are no u terms in the first two expression. Only here we are having 10u. So this gets multiplied with 0, 0, 10, which gets multiplied with u. Right. Now we are going to write the output matrix. Here y is equal to x1. Therefore, y is given by 1, 0, 0 multiplied by x1, x2, and x3. So here comes the end of the problem. If you have any doubt, let me know in the comment section. Here, once you draw the signal flow graph, then everything is very easy. Right. So if you have any doubt, let me know. Thank you.